take a look at part 2 of this assignment. And this is going to show how to use Project Reactor features, including fluxes and parallel fluxes, to download and store images from remote web servers. So slight different variant, basically the same idea in terms of how parallel processing is done. And we can find that also in the ex5 project in my Reactive Flux folder in the Live Lessons GitHub repository. So here we are back in the ex5 project. This time we're going to take a look at the test parallel downloads test method. And as you can see here, it's going to get a flux containing a bunch of URLs. Let's go take a look and see how that's going to work. In this particular case, we are going to take a bunch of image names. Here are the image names we've got. There's a whole slew of them. These all come from my website here at Vanderbilt. And we're going to call flat map, and we're going to convert this string into a flux. So let's go take a look at this. This is kind of a fun little helper method. So what this method does is it's going to take the array. This is the array of names. We were just looking at this big array up here. And it's going to take that array, and it's going to split it up based on the comma separator. And then we're going to concatenate the URL prefix, which is my website here at Vanderbilt, with each of the names of the images. And then we're going to map this using this URL factory function. And that's essentially going to convert each of those strings into a URL. And we use the rethrow function exception laundering technique here, so we can use things in this stream without having to deal with checked exceptions, which are super annoying, as you probably recall. So we end up here with a flux of URLs, and then we limit the number of them that we're going to take. And we just do this so we can run the tests with different numbers and see how that affects the performance. So that's what get URL flux does, fun little helper method. So now we have a flux of URLs, which we are going to run in parallel. And this time, we're going to run them on the bounded elastic thread pool. So if you recall our discussion from last class, bounded elastic is this thread pool that's able to expand and contract so that I/O-bound operations are going to run effectively. And good thing to remember how that works. Now what we're going to do is we're going to use map, and we're going to download and store each of the images in parallel. So let's go take a look at what we do here. So download and store image takes a URL and returns a file. And we're going to download the image at the URL. And you can see what this does is it's going to make a new image object that will include the URL as part of the image object, as well as the content downloaded from said URL. You can see here we have a little helper method that's going to open up a stream, an input stream that's connected to that URL. And then for each chunk, each buffer that we read from the socket that's now open to the URL, we're going to read it, write it into the output stream, the O stream. And then when we're all done, we return the output stream as a byte array. So we're going to read everything into a big byte array. That's going to be stored here into this image object. And the image object is just a simple data structure that keeps track of the buffered image and the source URL. So that's how we get there. So we download the image, and then we're going to go ahead and store it. And the store method is going to open up a file that's going to be on the local machine we've just downloaded everything to. And we're then going to create an output, a file output stream with this particular file name. And then we're going to write the contents to that output file. So that's how we're going to store the results. And then we're just going to return the file as the result from download and store image. So the way this is going to work is we're going to download and store the image. So you can see we're going to end up with a parallel flux of files that have been downloaded and stored in parallel. And then we're going to record some information about what happened. And then the final thing we're going to do is convert the parallel flux back into a flux. We then will print out some information about everything we've downloaded. And the final thing we do here, notice that this gets called when things complete successfully. So it's do on complete. If everything goes well, then we're going to print the results out. If there's a an exception that's not going to print the results. We then collect the results into a list, and then we go ahead and print out the size of that list and return a mono to a void. So that's how this particular test works. Let's now see what happens when we run the test for test parallel downloads. We'll rerun it. Shouldn't take as long this time because we've already compiled it. And here's what happens for test parallel downloads. You can see what it's doing is it's downloading each of these images from my website, and then it encodes them into a local file that is named based on the URL. We had to do some fancy footwork so the file names would be correct. And it also tells you the size of each of the files that's been downloaded. You can also see here, which I think is quite interesting, the numbers that are printed out here inside the square brackets are the threads where the computation is running. So you can see this is coming out of a pool of threads, and I think it starts here around thread ID 32 or so, and it seems to go to about thread ID 41 or so, and there are roughly 10 cores on my, or there are 10 cores on my computer, so you can see that we have roughly 10 threads that are running in parallel, and this is telling you the IDs of those threads. So that's just demonstrating how parallel flux is actually working in parallel under the hood in order to do all that downloading concurrently.